In the first lesson, we learned about utility, one of the key building blocks in capital allocation between risk-free and risky portfolios. It creates a basis for determining the value an investor would assign to a given portfolio. In this lesson, we'll learn another important concept, how to create a complete portfolio. To create a complete portfolio, we combine some ideal combination of risky portfolio with the risk-free asset. The complete portfolio includes risk-free securities, such as T-bills and money market fund denoted by F, and risky portfolio denoted by P. Let Y be the percentage of the total investment invested in the risky portfolio and 1 minus Y in the risk-free asset. The expected return of risky portfolio is denoted by R script P, and standard deviation is sigma P. For risk-free securities, expected return is R subscript F, and standard deviation is 0. The complete portfolio expected return is the weighted average of the returns between risky portfolio and risk-free assets. The variance for the complete portfolio is calculated as the weighted square of sums adjusted for covariance. The calculation for weighted variance is covered in details in BKM6. The standard deviation for complete portfolio is simplified to Y times sigma P. Let's derive the standard deviation of the complete portfolio. The complete portfolio variance, sigma C squared, equals Y squared times variance of the risky portfolio plus 1 minus Y squared times the risk-free security variance plus 2 times the weights times covariance between risky and risk-free asset. Since the variance for a risk-free asset is 0, the second term is 0, and the covariance is also 0. What's left is just Y squared times sigma P squared. Taking the square root, we have Y times standard deviation of the risky portfolio. We can express Y as sigma C over sigma P. Replacing Y with sigma C divided by sigma P in the expected return equation. We'll have more discussion on this equation later on after we go over the graph on CAL. Let's work on an example. The risky portfolio expected return is 15%. Standard deviation of the risky portfolio is 22%. Risk-free rate 7%. We can graph the risk-return relationship for the complete portfolio. On the graph, the x-axis is the standard deviation, and the y-axis is the expected return. The y-intercept is the risk-free rate, 7%. If we invest entirely in the risky portfolio, the expected return would be 15%, and standard deviation would be 22%. When we connect the 2 points with a straight line and extend it out, we have the capital allocation line, also known as the CAL. CAL describes the risk-return combination available to investors that can be constructed from the risk-free asset and risky portfolio. CAL equation is the second expected return equation we looked at earlier when we substitute Y with sigma C over sigma P in the original expected return equation. The slope of CAL is the expected risky portfolio return minus risk-free rate over sigma P. It's also known as the Sharpe ratio or reward to volatility ratio. It represents the increase in expected return per unit of additional standard deviation. We can also interpret it as incremental return per incremental risk. When all else being equal, investors want higher Sharpe ratio because it offers more return for additional risk. Complete portfolios and risky portfolio have the same slope or Sharpe ratio because they lie on the same CAL. We can borrow and invest more than our capital in the risky portfolio. In this case, Y would be greater than 1. These complete portfolios lie on the right of P. In the situation where investors cannot borrow at risk-free rate because of the default risk, they borrow at a higher rate than the risk-free rate. As a result, the CAL to the right of P would be kinked at P, as shown by the orange line. The borrowing rate replaces the risk-free rate in the CAL equation. Let's go over how to draw a kink CAL quickly. The x-axis is sigma, the y-axis is expected return. The y-intercept is the risk-free rate. Plot the risky portfolio P and then connect the y-intercept and P with a straight line. This is the CAL for y less than or equal to 1. For the CAL to the right of P, first, find the borrowing rate on the y-axis. Draw a straight line from this point going through P and extend it out. The line segment to the right of P is the kinked CAL. To recap, CAL shows all the complete portfolios available to investors between risk-free asset and a given risky portfolio P. At y-intercept, 100% of the capital is invested in risk-free asset and none in risky assets. At point P, 100% is invested in risky portfolio and none in risk-free asset. Between y-intercept and risky portfolio P, a positive portion is invested in risk-free asset and risky portfolio. To the right of P, money is borrowed and invested in risky portfolio in addition to investors' own capital. You can also interpret it this way. Investors short sell risk-free assets such as T-bills and invest the proceeds in risky portfolio. If you like our video lesson, you could find the entire Section A video lessons organized by chapter on our main website www.actuaryfellow.com. And the best thing is, it's free of charge. Plus, you could take our quiz to test your understanding of the key concepts for each video lesson. We also offer practice exams on our supplemental study website, www.actuaryfellows.com. Our practice exams are on CBT setting, the exact same way the actual exam is being administered. Sign up and access the free package, including past exams and all past integrated questions. Happy studying! Do it once and for all.